Hi, everyone. I'm Aaron Larson, executive editor of Power Magazine, and you are listening to the Power Podcast. On today's episode, I'm joined by Duke Energy's Senior Vice President and Chief Nuclear Officer, Stephen Capps. And from what I understand, your friends and colleagues call you Capps. Is it all right if I do the same?
Yes, sir. That'd be great.
All right. Thanks, Capps. So, to kick things off, can you just tell a little bit about yourself and your background?
Yes, sir, I can. So I grew up about 10 miles from Oconee Nuclear Station in the upstate of South Carolina. I went to school at Clemson University and got a mechanical engineering degree. And while I was in school at Clemson, I actually worked at Oconee in the summer and just had an affinity for the place. A power plant's kind of like a playground for an engineer, just all the systems, all the equipment. And so I was fortunate enough when I graduated from Clemson to get a job at Oconee. And I spent 20 years there in engineering and operations, did a lot of different things in engineering, and then spent a little bit of time on shift as an operator. And then moved to McGuire and spent about a decade there, and then have been in different roles in our corporate organization for the last 8 or 9 years.
For Duke Energy, nuclear power is really vital to your overall generation fleet. Can you talk a little bit about its importance and the history behind it? I know you've got many plants. Maybe you can touch on some of them and how they've been instrumental in the utility.
Yes, sir, I can. So we operate 11 units in the Carolinas at 6 different sites. Nuclear produces about 11,000 megawatts here in the Carolinas. Our oldest plant started up in 1970. That would be the Robinson nuclear plant, and then our newest plant started up in 1986. So, kind of 6 sites, 11 units spread out over about a decade and a half. Nuclear produces over 50% of the energy used in the Carolinas year in and year out. So it is a cornerstone of our generation portfolio.
I know those plants have been operating very well. If I'm not mistaken, you set a new capacity factor record just last year. Can you talk about the improvements and what's led to that type of performance?
Yes, sir. 2025 was the best year we have had in terms of overall capacity factor for the fleet. And we had a capacity factor above 97% for the collective fleet. And I think it's really a manifestation of two things. One is the ongoing maintenance and capital investment that we have done at the stations to keep them reliable from an equipment perspective. And then we have spent a great deal of energy as an organization the last few years focusing on identifying and managing risk. And I think that has also helped us from a generation and operation standpoint.
We went through a period where a lot of nuclear plants were kind of on the chopping block. We saw several get shut down due to economic reasons, and now some of those are being brought back. I don't know if Duke Energy ever had any conversations about potentially shutting down plants, but how have you seen this trajectory change in recent years, and what has it meant to you?
I mean, certainly nuclear has gained favor in the recent past, both the operation of the existing fleet and then a lot more discussion in the US about building new nuclear plants.
Have there been any discussions in your offices about adding new plants or increasing the number of units at any of the existing sites?
Yes, sir. We have an integrated resource plan that currently reflects new nuclear in the Carolinas in 2037. So we are going through an internal process right now. We call it a decision-making framework to determine a path forward for new nuclear for Duke Energy. We are considering a number of sites in the Carolinas, and then we are also evaluating a number of technologies as a part of that.
Mhm. And I'm guessing you probably can't talk about any that are really high on the list at this point?
Really no decisions at this point.
I know the Robinson plant recently got a license extension that would allow it to operate up to 80 years. Are there other plants in your fleet that you're looking to extend in a similar manner?
Yes, sir. Our intent over time is that we will go through the subsequent license renewal process for our entire fleet. We got approval for the Oconee Nuclear Station, those 3 units, last year in 2025 in April to operate for 80 years. And then, as you said, a couple of weeks ago, we got approval for our Robinson nuclear plant to operate for 80 years. So that allows it to operate until 2050. And then the latter part of this year will make our subsequent license submittal to the NRC for the Brunswick nuclear plant. So our intent over the next few years is we would go through the subsequent license renewal process for the entire fleet to be able to operate each plant for 80 years.
It's exciting to see these plants that have been there and been so well run get extended and continue to be part of the discussion. Can you talk a little bit about uprates and ways that you can add more megawatt output from some of the plants that are already out there and existing?
Yes, sir. So we have a number of plants that have already been uprated. Really, they were uprated a couple of decades ago, around we'll say the early 2000s. But we have several units that were not uprated. In particular, the 2 units at McGuire and Catawba Unit 1, we are in the process of doing uprates on. And we'll be able to increase the output of each one of those units approximately 75 megawatts. There's a modest capital expense that goes with it because there are a number of secondary side components. Think things like feed water heaters, moisture separator reheaters, some of the large secondary pumps and motors that we'll have to replace to accommodate the increase in power. But it'll essentially allow us to get a bit more out of each of those units for a modest capital investment and essentially the same ongoing O&M cost.
For listeners that may not know what goes into an uprate, can you talk about what goes into that process?
Yes, sir. So the way to think about it is a reactor's rated for a certain thermal megawatt output, and that kind of dictates the way we design and load each core. And when we go through the uprate process, there's a large analytical and licensing piece of it as well. But we will essentially increase the allowed megawatt thermal output of the plant, which will allow us to load fuel that's enriched a bit more and get a bit more thermal output from the plant, which will translate into about a 75 megawatt electrical output increase.
And how important is that? Is that allowing the company to not have to build some new plants?
I mean, a way to think about it is with the uprates at Catawba and McGuire and a couple of smaller measurement uncertainty recapture uprates that that we have done or are doing at Oconee and Brunswick. we'll get about 300 megawatts of capacity, which is the equivalent of a small modular reactor. So it'll certainly help us serve the load. We are in a period of growth right now, so we will continue to have to build generation to serve the increase in load demand, but certainly an additional 300 megawatts of nuclear capacity will help us serve the load and provide a clean energy source as well.
Mhm. So, thinking about the future and some of the technology that is out there, how do you go about evaluating whether to build a small modular reactor or a gigawatt scale reactor? What sort of process do you have for making that decision?
You know, it's like a lot of other things. There are pros and cons to each, to a small modular reactor or a large light water reactor. And we have a really there's two things. There's a technology framework that EPRI and the industry has put together to evaluate each plant or each technology, and we have made use of that in terms of evaluating specific reactors or reactor types. And then and this decision making framework that I referenced earlier that we're going through now, it includes the site selection, the technology selection, those things, but it also has a significant piece that deals with the economic and financial aspects of building a new plant, which is probably the biggest consideration.
Yeah, when I've looked into some of the metrics and whatnot for Duke Energy, and I know you're among, if not at the top of the list for economic power that's, provided to your customers. And so do you worry at all about cost overruns and how that could affect your customers in the long run?
I mean, oh sure, I think in the sense that that anytime you undertake a large capital project, you've got to have an eye towards how you will manage the risk and how you will ensure that you're predictable relative to the schedule and to the cost.
Mhm. Thinking about new engineers coming out of college or out of the military and looking for a career in nuclear power, what would you say to them with your knowledge of the industry and what you've been able to accomplish in your career?
I think it's a fantastic career for an engineer for a number of reasons. Um, One big one is just there are a lot of different opportunities. If I think back on my own career, even the engineering part of it, I probably had 10 or 12 distinctly different jobs or roles in engineering. And I mean, each one of them gave me an opportunity to learn something new, gave me an opportunity to develop a new or different set of skills. So it's just, it's a very technical um, business, but it's a very broad, very diverse environment. So you just have an opportunity to see a lot of things and do a lot of things from an engineering perspective.
All right. Well, Caps, it's been a lot of fun talking to you. Is there anything that I haven't asked about that you think might be important to touch on?
I mean, you've covered a lot, Aaron. I would just say that for us, the things we talked through today, we kind of couch it as today, tomorrow, and the future. When we're talking about nuclear internally, today is the safe, reliable, cost-effective operation of our existing fleet. Tomorrow we look at as the nearer term. So it's those things like subsequent license renewal, uprates that will give us additional life and additional capacity. And then the future is where we put new nuclear and the work we're doing to plot a path there.
All right. Well, thank you again for your time. For listeners, I've been speaking with Stephen Capps, Senior Vice President and Chief Nuclear Officer with Duke Energy. It's been a pleasure having you on the podcast.
Thank you, Aaron.